For this problem, we will be using a little bit of our knowledge of calculus in solving kinematic problems. Like for example, on this problem we are being asked to find the velocity. We are asked to calculate the instantaneous velocity. The instantaneous velocity of a particle traveling along a straight line for time t equals 3 seconds with a function x is equal to 5t squared plus 2t plus 3. So this is a position vector, or it's a function of the position of a particle. Now if we'll try to find for the instantaneous velocity of this particle, we need to remember our knowledge on calculus. So the given we have the function, we have the given function, which is 5t squared plus 2t plus 3, and then the time is given so the function is 5t squared plus 2t plus 3, and the time is 3 seconds. Okay, so we are required to get the instantaneous velocity for this problem. Now if you will remember that velocity is the derivative of the position with respect to time. So we have velocity is equal to dx over dt. Okay, the derivative of x with respect to time. Now we have a function. A function is given where x is equal to 5t squared plus 2t plus 3. We'll just have to derive this function for us to arrive on velocity. Okay, so if you'll remember our calculus, differential calculus, we'll just have to derive this function. So it is a derivative of the function 5t squared plus 2t plus 3 with respect to time. By just distributing the derivation for this function, the derivative of 5t squared is equal to 2 times 5. We have to multiply the exponent 2 to the numerical coefficient of this term. So 2 times 5 is 10. Then we need to subtract 1 to its power, which is or the exponent, which is 2. So 2 minus 1 is 1. Therefore t will just be raised to the power of 1. That's why we'll have 10t. Then using the same differentiation to this term 2t, so it is understood that t is raised to 1. 1 times 2 is 2. Then understood that it has a power, an exponent of 1. 1 minus 1 is 0. And t raised to 0. So any number raised to 0 is 1. That is why it will just be equal to 2 times 1 or 2. And the derivative of a constant of this term 3 is of course 0. That is why the velocity function is 10t plus 2. Now we have been given by time 3 seconds. If we are given a time 3 seconds, we just have to substitute this time to our velocity function. So from our velocity function and substituting 3 seconds, we'll have v is equal to 10 times 3 plus 2, which is equal to 30 plus 2, and adding this, we'll have the velocity equal to 32 meters per second. So that's just how we can solve for the velocity, the instantaneous velocity on a specific time. That is why it is called instantaneous velocity, because we are looking for the velocity on this instant, on this given time. So we have been given by a position vector or a function, and we just derive this function to arrive on the velocity, and we just have to substitute the given time to get its instantaneous velocity. So that's how simply we can solve for the instantaneous velocity of a particle.